Hey everyone, welcome back to the channel. Today we are diving into one of Python's most powerful features, the use of args and kwargs. If you have ever wondered how Python functions can accept a variable number of arguments or how decorators and complex function signatures work, this is the video for you. We'll be exploring not just the basics but the complex differences between args and kwargs, how they interact in real world scenarios like class inheritance, function overloading, and decorators. By the end of this video, you'll have a solid understanding of how to use these features to write more flexible and dynamic Python code. So let's get started. Part 1, Introduction to args and kwargs. Alright, let's talk about two cool features in Python that make your function super flexible. Args and kwargs. Imagine you got a function and you don't know how many arguments people will pass. Maybe it's 2, maybe it's 10. That's where args comes in. Think of it like having a bag where you can throw in as many items or arguments as you want, and when you open the bag, the function processes each one individually. It collects all the positional arguments into a tuple, so you can loop through them easily. It's perfect when you're working with an unknown number of inputs. Now, quartz is a bit different but just as useful. Instead of a bag, picture a toolbox. Each tool has a label, and that label is like the name of the argument. When you pass keyword arguments to a function, quartz collects them all into dictionary. This way you can access each argument by name and handle them one by one. It's super handy when you need to pass flexible named parameters, like when you're working with settings or configurations in a library or framework. So args helps when you need to handle multiple unnamed positional arguments, while kwargs is great for handling named arguments that act more like settings or options. And the best part, you can even use them together in the same function. Alright, let's kick things off with an introductory example to really see how args and kwargs work. In this example, we have a function called sum underscore numbers that uses args to accept a variable number of positional arguments. The arg syntax allows the function to collect all the arguments passed into a single tuple, which can then be processed inside the function. Here is how it works when you call sum underscore numbers 1, 2, 3. Python automatically packs the numbers 1, 2, and 3 into a tuple. Inside the function, the for loop goes through each number in the args tuple, adds them together, and stores the result in the total variable. After the loop finishes, the function returns the sum. In the first example, the function adds 1, 2, 3 and returns 6. In the second example, where we pass 5, 10, 15, 20, it adds these numbers together and returns 50. The beauty of args here is that it makes the function flexible enough to handle any number of arguments, whether it's 3 or 4 or more, without needing to modify the function signature. In the next example, we have a function called greet that uses kwargs. The kwarg syntax allows the function to accept a variable number of keyword arguments. When the function is called, Python packs the keyword arguments into a dictionary, where each key is the argument name and each value is the corresponding value passed. Let's break it down. When you call greet name John, age 25, city New York, Python takes this keyword arguments name John, age 25, and city New York and creates a dictionary kwargs name John, age 25, city New York. Inside the function, the for loop iterates over the kwargs.items, which returns key value pairs from the dictionary. For each key value pair, the function prints them in the format key value. Part 2, simple differences. Alright, now that we've covered the basics of args and kwargs, let's dive into the simple differences in a more structured way. We'll compare them side by side so you can really understand how they operate and how they can be used in your Python functions. This comparison will break down everything from how they handle arguments to how they're written in function definitions. Let's take a look at the simple differences between args and kwargs. Definition: args and kwargs serve different purposes in a function. Args is a way to pass a variable number of non-keyword arguments to a function. Essentially, you're telling the function, I don't know how many arguments I'll be passing, but here they are, all as positional arguments. On the other hand, kwargs lets you pass a variable number of keyword arguments, where each argument is associated with a name, key, and its corresponding value. Argument type: when you use args, you're working with positional arguments. The function just receives values in order. So if you call a function with 1, 2, 3, those values are packed into args. Meanwhile, quarks accepts keyword arguments where each argument has a name like name John or age 25, allowing the function to work with name parameters. Data structure inside the function, args is treated as a tuple. That means once the function gets the arguments, they're neatly packed into a tuple, which you can iterate over or access by index. For quarks, the keyword arguments are stored in a dictionary where you can access the values by their corresponding keys. Usage syntax in the function definition. Args is written exactly as args. That's how Python knows to treat the incoming arguments as positional. Similarly, kwargs is written as kwargs in the function definition, signaling that any keyword argument should be packed into a dictionary. The purpose of args is to allow a function to accept any number of positional arguments, meaning you don't need to know ahead of time how many arguments will be passed. It's flexible for when you need to process multiple items. On the other hand, quarks allows the function to accept any number of keyword arguments, which is great for passing name parameters, often used for configurations or options. Unpacking args can unpack positional arguments from sequences like lists or tuples. For instance, if you pass a list to a function using args, it will unpack the list and treat its elements as individual positional arguments. Similarly, quarks can unpack key value pairs from a dictionary, meaning you can pass a dictionary and the function will treat the key value pairs as keyword arguments. Order of arguments in a function definition. If you're using both args and kwargs, the order matters. Args must come before kwargs. You can't have keyword arguments before positional arguments. So this order ensures Python knows what goes where. Data storage. Once the arguments are passed, args stores all the positional arguments in a tuple. This makes sense because tuples are ordered, and that's exactly how positional arguments work. They're received in the order they passed. On the other hand, Quark stores keyword arguments in a dictionary, where each argument's name is the key and its corresponding value is the dictionary value. Used with other args, both args and quarks can be used together in the same function definition. You can combine args with regular positional arguments and quarks with keyword arguments, giving you incredible flexibility. For example, you can have a function that takes specific required arguments and then a number of additional positional or keyword arguments. Common usage. The typical use case for args is when you don't know how many positional arguments will be passed to the function ahead of time. It's common in mathematical functions or in cases where you need to loop through a list of inputs. For kwargs, it's often used when you need flexibility with named parameters such as configuration settings, where you want to pass options without hard coding them into the function signature. Example call. A typical example call for args looks like this: func1, 2, 3, where the arguments are passed as positional values. For kwargs, the example call would be func1, b2, c3, where the arguments are passed as keyword value pairs. Part 3, hands-on examples for simple differences. Example 1, example for args positional arguments. In this example, we have a function called sum underscore numbers that uses args to accept any number of positional arguments. The arg syntax allows the function to pack all the extra arguments into a tuple, which can then be processed inside the function. Here's how it works. When you call sum underscore numbers 1, 2, 3, Python automatically packs the values 1, 2, and 3 into a tuple called args. Inside the function, we use a for loop to go through each value in the tuple and add them to the total variable. Once all values are added, the function returns the sum. For the first call sum underscore numbers 1, 2, 3, the result is 6 because 1, 2, 3, 6. In the second call sum underscore numbers 10, 20, 30, 40, the function sums these numbers to return 100. The key idea here is that the function can handle any number of arguments without needing to change the function signature, making it very flexible for different input sizes. Example 2, example for quarks keyword arguments. In this example, we have a function called print underscore person underscore info that uses quarks to again a number of keyword arguments. The quark syntax collects all the keyword arguments into a dictionary where the argument names are the keys and their values are the corresponding dictionary values. Here's how it works when you call print underscore person underscore info name John, age 30, city New York. Python packs these keyword arguments into a dictionary like name John, age 30, city New York. Inside the function, we use a for loop to iterate over the dictionary using kwargs.items, which gives us the key value pairs. For each pair, the function prints out the key and its corresponding value. Example 3, example combining args and kwargs. In this example, we have a function called process underscore data that uses both args and kwargs to accept any number of positional and keyword arguments. The arg syntax allows the function to collect all the extra positional arguments into a tuple, while the kwarg syntax gathers all keyword arguments into a dictionary. Here's how it works when you call process underscore data 1, 2, 3, name Alice, age 25. Python automatically packs the values 1, 2, and 3 into a tuple called args and the keyword arguments name Alice and age 25 into a dictionary called kwargs. Inside the function, we print both the positional arguments and the keyword arguments. For this example, the function prints the tuple 1, 2, 3 as the positional arguments and the dictionary name Alice, age 25 as the keyword arguments. This demonstrates that the function can handle both types of arguments simultaneously, making it highly flexible for processing mixed inputs. Part for advanced and complex differences. Now that we've covered the basics, let's dive into the complex differences between args and kwargs. These differences will help you understand how these two features work on a deeper level, especially when it comes to advanced use cases like function overloading, decorators, class inheritance, and performance considerations. Whether you're designing more flexible functions or customizing function signatures, these distinctions will give you a better grasp of how args and kwargs can work together to enhance your Python code. So let's break it down step by step. The primary function of args is to allow you to pass a variable number of positional arguments to a function. These arguments are collected into a tuple, so the function can handle multiple values without predefined argument names. On the other hand, quartz allows you to pass a variable number of keyword arguments, which are collected into a dictionary. This makes it possible to pass flexible key value pairs to a function. How it's defined args is defined in the function signature using an asterisk followed by a name commonly args, though you can use any name. Similarly, quarks is defined with two asterisks followed by a name commonly quarks. This tells Python to handle the incoming arguments as a tuple for args and a dictionary for quarks. Argument order when using both args and quarks in a function signature. Args must always appear before quarks. This is because positional arguments need to be collected before keyword arguments are handled. If both are used, quarks should always follow args in the function signature. Argument handling args collects all additional positional arguments into a tuple, allowing you to pass multiple arguments without specifying their names. In contrast, Quarks collects additional keyword arguments into a dictionary, allowing for flexible key value pairs that can be passed into the function. Order of precedence positional arguments, including those captured by args, must be passed before keyword arguments, including those captured by quarks. This ensures that Python knows how to separate positional arguments from keyword arguments during function calls. Flexibility in function design args allows for flexible function definitions, especially useful in decorators or wrappers that need to accept arbitrary positional arguments. Similarly, quarks is valuable for designing functions that need to handle named parameters dynamically like configurations or options. Defaults with function signatures args does not handle default values directly. Default values need to be specified separately in the function signature. However, quarks is often used to provide flexible keyword arguments, allowing for default values in a more dynamic way. In decorators, args is frequently used to ensure that the decorated function can accept any number of positional arguments. Similarly, quarks is used in decorators to handle arbitrary keyword arguments, making the decorated function more adaptable to varying inputs. Function signature flexibility args allows functions to accept any number of positional arguments, giving flexibility without knowing the exact count in advance. Quarks provides similar flexibility for keyword arguments, allowing functions to accept dynamically named parameters. Positional argument unpacking args can unpack positional arguments from sequences like lists or tuples. For example, If you pass a list using args, the list will be unpacked and its elements will be treated as individual arguments. Similarly, kwargs can unpack key value pairs from a dictionary, passing them as keyword arguments. Keyword only arguments args cannot directly handle keyword arguments, but it can work alongside kwargs to allow positional arguments first, followed by keyword arguments. Kwargs, on the other hand, allows for flexible keyword only arguments, ensuring name parameters are explicitly passed. Performance consideration: while args makes it easier to handle multiple positional arguments, having too many can make argument management more complex. Similarly, handling many keyword arguments with kwargs might slightly affect performance due to the overhead of managing a dictionary. Function overloading emulation: args enables the emulation of function overloading by accepting varying numbers of positional arguments. On the other hand, kwargs allows more flexible function overloading by accepting a varying number of keyword arguments. Extending built-in functions: when extending or wrapping built-in functions, args is used to pass an arbitrary number of positional arguments. Meanwhile, quarks is ideal for passing additional name parameters when extending or wrapping built-in functions, allowing more custom behavior using class inheritance. In class inheritance, args can be used to pass positional arguments to parent class constructors without needing to know the exact number. Quavers is similarly useful in passing named arguments to parent class constructors, ensuring the child class can adapt to different configurations. Combining with other parameters: both args and quarks can be combined with regular parameters to create more flexible function signatures. This allows you to handle fixed, positional, and keyword arguments within a single function definition. Callable objects with flexible signatures in decorators or higher order functions. Args is often used to handle functions with uncancelable non-positional arguments. Similarly, quarks is used when handling functions with unknown keyword arguments, making it a valuable tool in modifying function behavior dynamically. Used with mixed signatures, args can be combined with required positional arguments and default arguments to create flexible function signature centers. Likewise, quarks can handle flexible keyword arguments in addition to any default keyword arguments. This makes both args and quarks valuable for creating highly adaptable functions. Part 5: hands-on examples for complex differences. Example 1: using args and quarks together. In this example, we have a function called demo underscore function that takes both positional arguments and uses args and quarks to handle additional arguments. The arg syntax allows the function to pack extra positional arguments into a true, and quarks packs any keyword arguments into a dictionary. Here's how it works when you call demo underscore function 1, 2, 3, 4, x10, y20. Python assigns the first two arguments, 1 and 2, to the positional parameters a and b. The remaining positional arguments 3 and 4 are packed into the tuple args. Meanwhile, the keyword arguments x10 and y20 are stored in the dictionary quarks. For the first two parameters a and b, the values 1 and 2 are printed as expected. Then the args tuple 3, 4 is printed, which contains the extra positional arguments. Finally, the quarks dictionary x10y20 is printed, showing the keyword arguments. The key takeaway is that this function can handle a flexible number of both positional and keyword arguments, making it adaptable to various input configurations without needing to modify the function signature. Example 2: order of arguments and default values. In this example, we have a function called example underscore function that accepts a combination of regular positional arguments, default values args for additional positional arguments, and kwargs for keyword arguments. This makes the function highly flexible and able to handle a variety of input types. Here's how it works when you call example underscore function 1, 2, 10, 20, x30, y40. Python assigns the value 1 to the parameter a and the value 2 to the parameter b, which has a default value of 5, but is overridden here. The additional positional arguments 10 and 20 are packed into a tuple called args. Meanwhile, the keyword arguments x30 and y40 are packed into a dictionary called kwargs. For this call, the function first prints a 1 and b2, whereas the regular positional argument and b is also a positional argument, but its default value of 5 has been overridden by the value 2 passed in the function call. Next, the function prints args 10, 20, which contains the additional positional arguments that were passed after the regular ones. Finally, the function prints quads extra d40, showing the keyword arguments that were passed as key value pairs, where x is 30 and y is 40. This output demonstrates the flexibility of handling both positional and keyword arguments within the same function. Example 3, using args and kwargs in class inheritance. In this example, we have two classes, parent class and child class. The child class inherits from parent class and both use args and kwargs to handle flexible positional and keyword arguments. This demonstrates how argument passing works in inheritance when dealing with args and kwargs. Here's how it works when you create an instance of child class by calling child class child1 10 20 age 30 city New York. The first argument child1 is passed to the name parameter of the child class. The remaining positional arguments 10 and 20 are packed into args, while the keyword arguments age 30 and city New York are packed into kwargs. Inside the child class constructor, the child specific name is printed and then the super function is called, which invokes the underscore underscore init underscore underscore method of parent class. At that point, the args and kwargs are passed to the parent and the parent class prints them as well. Here's the output. The child class first prints child name child1, reflecting the name argument passed to the child. Then when the parent class is called through super, it prints parent args 10 20, which captures the additional positional arguments passed to the child 10 20. Lastly, the parent class prints parent quads age 30 city New York, displaying the keyword arguments age and city passed to the parent class. This demonstrates how both positional and keyword arguments can be handled across parent and child classes in inheritance. Example for positional and keyword argument unpacking. In this example, we have a function called example underscore unpacking that takes both args for positional arguments and kwargs for keyword arguments. We demonstrate how to unpack a tuple and a dictionary into this function using the AND operators. First, we define two variables positional underscore args, which is a tuple containing the values 1, 2, 3, and keyword underscore args, which is a dictionary containing x10, y20. When we call example underscore unpacking positional underscore args, keyword underscore args, Python unpacks the tuple positional underscore args into individual positional arguments 1, 2, and 3. And the dictionary keyword underscore args into keyword arguments x10 and y20. Inside the function, the unpacked values are printed the tuple 1, 2, 3 is displayed as the positional arguments, and the dictionary x10, e20 is displayed as the keyword arguments. This technique allows you to pass pre-structured data, such as tuples and dictionaries, into a function that accepts flexible arguments, making it easier to handle multiple values efficiently. Example 5, using args and kwargs in decorators. In this example, we demonstrate how a decorator works with args and kwargs. We define a decorator called decorator that wraps around the function it decorates. Inside the decorator, there's an inner function wrapper that accepts both positional args and keyword arguments kwargs. The purpose of wrapper is to intercept the arguments passed to the original function, print them, and then pass them to the original function using funcargs kwargs. Here's how it works when you decorate the greet function with that decorator. The greet function gets wrapped by the wrapper function from the decorator. Now, when you call greet John age 30, the decorator's wrapper first prints the values of args, in this case John and kwargs age 12. After printing these values, it calls the original greet function, passing the arguments along. The greet function itself takes a name and an optional age argument. In this case, greet John age 30 prints the message hello John age 30. Example 6, callable and sentinel in kwargs. In this example, we have a function called configurable underscore function that accepts both positional arguments using args and keyword arguments using kwargs. The key feature of this function is that it checks whether the keyword argument debug true is passed, allowing for a configurable behavior based on the input. Here's how it works when you call configurable underscore function 1, 2, 3 debug true. The positional arguments 1, 2, and 3 are packed into the args tuple, and the keyword argument debug true is stored in the kwargs dictionary. Inside the function, the line kwargs.getDebug false checks if the keyword argument debug is set to true. If it is, the function prints debug mode on. After that, the function prints processing followed by the positional arguments 1, 2, 3. For this specific call, since debug true is provided, The function first prints debug mode on and then prints the positional arguments as processing 1, 2, 3. This setup allows you to toggle debug mode dynamically by passing a keyword argument, making the function more flexible and configurable. And that's it for today's video. We've covered the intricate details of args and kwargs and how they can be used together in some really flexible and powerful ways, from handling unlimited positional and keyword arguments to extending built-in functions and working with decorators. These features truly unlock the full potential of Python's dynamic nature. If you found this video helpful, be sure to give it a thumbs up and subscribe for more Python tutorials and programming tips. Don't forget to leave a comment below if you have any questions or suggestions for future videos. Thanks for watching, and I'll see you in the next one.